In this video we're going to look at how to calculate mean and standard deviation for normal distribution problems. So this first question here, we're told that a distribution for x is a normal distribution and that it has an unknown mean at the moment, which is just down here as mu, and that we've got here a standard deviation of 2, and we know the probability that x being less than 10 is equal to 0.8643, and I want to find the value here of mu. So what do I know about this? Well, I know that I've got a probability of 0.8643 and it's less than something, so I know I'm talking about quite a large area here. And I know in terms of x that this number here is 10, but I want to find out what it is in terms of z. So the probability that z is less than z is equal to 0.8643. So therefore z is something I can look up. So 8643 is down here, gives me 1.1. And so then I can use my transformation formula. So I know that 10 subtract the mean divided by the standard deviation of 2 is equal to 1.10, because I know it's 1.10 standard deviations above the mean, so this is going to be able to work that out. So from here I know that mu must be 10 subtract 2 multiplied by 1.10, which is then 10 subtract 2.2, which is then 7.8. Second question here, much the same kind of idea, so let's just do a quick sketch. So what do I know about this? I know I've got a probability of 0.025, so a very tiny probability, and it's this value here. I know that's 18 in terms of x, but I want to know it in terms of z. So I want to find here the probability that z is greater than z. I know that probability, sorry, is 0.025. So what value of z do I get from that? Well, if I use my small table, 0.025 as a probability is 1.96 as a value of z. So now I know that 18 subtract 15 over the standard deviation is equal to 1.96. So from there I know that 18 minus 15 I know is 3, so 3 is equal to 1.96 rho, so therefore rho is 3 divided by 1.96, and that gives me a value of 1.531. So final question here, this time I've got both mu and rho as unknowns, but I'm given two different bits of information about probability. So let's look at this first one. So x is less than 20 is 0.9564, so that's a pretty large probability over here. And I know what that probability is. So the probability that z is less than z, we have this here as z, is equal to 0.9564. So from there I know that z, well, let's look it up in the table. So 9564 is here, it gives me 1.71. So from here I know that 20 subtract mu over rho, over sigma even equals 1.71. So that 20 minus mu equals 1.71 sigma. Now if I do a similar kind of idea for the other bit of information, I'm going to have two equations in terms of mu and sigma, and I can solve those then simultaneously. So over here I know the probability that x is less than 9 is 0.1151, so I've got a very tiny probability over here. So then I can use symmetry. So that's equal to this area here, and I can work out this white area. So this white area here is going to be, let's have a look, going to be a probability here of 0.8849, and that's 1 subtract the probability that I do know, which is the shaded area. So can I look up 0.8849 in the table? I can, and I get 1.2. So this value here is 1.2, so that means this value is negative 1.2. So I know here that 9 subtract mu over sigma is equal to negative 1.20, and therefore 9 subtract mu equals negative 1.20 rho. So I've got two equations here that I can work on simultaneously. So if I do equation 1 subtract equation 2, on the left hand side I get 11, and on the right hand side I'm going to get here 2.91 sigma. So then I can solve for sigma. And I get sigma here being 3.78. And then I can substitute that value into one of my other equations. So if I sub into equation 1, I can say 20 subtract 1.71 times 3.78 is equal to mu, and here for mu gives me an answer of 13.54. Again, if I do this to 2 decimal places, it's always worth doing a little check at the end. Does this seem reasonable? Let's have a look. I knew from here probability that x is less than 20 is that, so I knew that the mean has got to be less than 20. I know from this probability that the mean's got to be greater than 9. Yep, that seems to fit okay.